that's going to be in a format that you prefer. Okay. All right. Let's see. I think we're good for list. I think we're ready to go to the next lesson. All right, so we're going to now go to for loops. So I'm going to the next section, for loops. Not for loops, but for loops. All right, let's check it out. An example, for loops. All right, so what does that mean, a for loop? Well, a loop is going to be something that allows us to do something over and over repetitively, but in a nice, concise block of code. All right. So if I wanted to do something, let's say, like to a list of numbers, let's make a list of numbers. So like 2, 3, 5. Okay. To make it look nice. So I have this list of numbers. That's nice. But maybe I wanted to print each one, right? So I wanted to print just the 2. Then I wanted to print just the 3, and then just the 5. So it's like, okay, well, I guess if I save the, I can print 2, I can print 3, print 5 manually. There's a few ways. Pretty tedious. I could do that. Imagine if this list was like 20 different values, 20 different elements. Then this is going to take too long. So I don't want to do that. So maybe you think, well, then I can also like print each individual index. Like I could do 0 like this, right? 0, 1, 2, 3. But that's still going to be repetitive. I don't want to do that. I want something to know that for every, you hear the word for every value in this list, I want it to print. Okay. So turns out you can do that using the for loop. And remember, I just said for every number in this list, I want it to print the number. Whoa, it's almost like it knows what I'm doing just from saying it. So for every number in this list, I want to print the number, and that's what I want. Okay, so let's take a look at how is this working. All right, well, we just called the for loop statement. And what that's going to do is it's going to look at something called an iterable, meaning something that can be looked at repetitively. And then it's going to do whatever you want for every element in that iterable. In this case, we have a list, and that has 3 values. So for every number in this list, it's going to print it. All right. Probably something that is kind of strange, like, wow, how did it know it's a number? It doesn't know. This word number, it's a placeholder. Basically, it's referring to each value of this list, right? You can think of it as like a loop variable, all right? So this loop variable, it could be whatever you want. So for every, I don't know, fruit, print the fruit. Is that a fruit? No, but what does it care? It doesn't know, right? So this is just basically a placeholder called a loop variable. It's going to refer to each one of these values independently. Okay, but I'm going to change it back to number just so I'm not confusing you. Yeah, you can even use a single letter, like for I, print I. That works too. Those of you in math are more likely to probably use these. In programming, tend to use more something that when a human looks at it, they know what this is referring to, right? But it really, anything will work. Okay, good. Here I printed each one. So basically, this is what it's going to do. So for number in this list, so first step is it's going to go and say, okay, we're now in the first value, which is 2. It's going to go and look in what's called the body of the loop, basically everything underneath this, and then do it. All right. After it's done, it's going to go to the next one, and then look at the body of the loop, and then do it again. It's going to keep going until there's nothing left to do. All right, so because 5 is the last number in this list, it's going to stop at 5. It's not going to keep going. All right. And if we look at this one right here, what's something that's kind of sticking out, like something that seems different? You notice this thing right here? That's an indentation or a tab, right? That's very important. In order for a loop to work, you must have this tab, or you can use 4 spaces, so like space, 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 space. But without it, it's not going to work. So you get rid of it, it won't work. Indentations are very important in Python. They have meaning to it. Okay, so we got to have that in there. The other thing is, for the loop to be specified, the body of it, you have to have a colon there. All right. So if you don't have that, it's not going to work. So don't forget the colon and don't forget that indentation. All right. So what else can we do with this? Well, we can, besides printing, let's do some math. So let me make a new one. I'll make a list of primes again. And what do I want to do with it? So for every, and again, I can put number, I can put anything I want. I'll just say P, because it's like math, right? So for every P in primes, do what? And notice when I press enter or go to the next line, it already indented for me. It knows that you're about to write the body of the loop. So what do I want to do with it? Maybe I want to square the number, right? We could do some math. So I'm going to make a squared number. And the squared number is going to be, well, in exponents for Python is double asterisk. So P to the power of 2. Or you can do P times P, that's fine. And then maybe I want to cube the number. And that's going to be P to the power of 3. So I'm just doing some math on it. Right? I'm doing some kind of calculation where it's going to be repetitive, and I can rely on this for loop to do it multiple times much more easily than calculating square root of 2, cubed of 2, next, square root of 3, cubed of 3, next. Much easier to have it do it automatically. And then what do I want to do? I want to actually have it print so I can see the original number, which is P, the squared number, and the cubed number. Okay, maybe I'll add some more notes. So original, squared, and then cube. Let's see what happens. Look at that. That was a lot of output for just this much code, right? So instead of squaring each one manually, we were able to do it programmatically using this for loop. Make sense? Good. Okay, very good. Let's add some more stuff to our loop, to our loops that we could do. All right. So this was an example of a list as this iterator thing, right? So for P and primes, And this works the same way with strings. So if this was a string, you can also use it in a loop. All right, so lists will work. Let's try a different object or a different iterator called a range, right? So range is useful when you don't feel like doing like, if you're going to be doing something where it's always going to be like 0, 1, 2, 3, 4, 5, and you don't feel like doing 0, 1, 2, 3, 4, 5, right? You can use this range object. So for number, and maybe I want to do like 0, 1, 2. Okay, so I could do 0, 1, 2, or I can use range. All right, so 0, comma, and if I want 0, 1, 2, it's similar to like a list slice. I'm going to put the number I want it to stop at and not include. All right, so I don't want 3. I want 0, 1, 2, stop at 3, don't include 3. So I'll put range 0, comma 3, meaning 0, 1, and 2 don't include 3. Okay, and then I could do something like print it, for example. Ta-da! 0, 1, and 3. This 0 is actually redundant. The reason I put it here is because you can start wherever you want. Maybe I want to start at 1 and go up to like 4 and don't include 5. So I want 1, 2, 3, 4. I can say start at 1 and then go up to 4, stop at 5, don't include it. But if I know I'm going to start at 0, then you don't have to put 0, comma. You can just put the number. It's assumed that you will start at 0 unless you tell it otherwise. So range 5, it means you're going to include 0, right? But if you didn't want to, you want to start somewhere else, then you can tell it where you want to start. So far, so good. All right, help me out. I want to add up the first 10 integers. So 1 plus 2 plus 3, blah, 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 up to, let's do up to 9. All right. So whenever I want to do something like this, I need somewhere to save the information as it's going to be added. So I basically want it to be start somewhere and then add 1, and then add 2, and then add 3, and then add 4. All right. So I need like somewhere it can be saved, because as it's going through this list, I needed to remember what the last value was. In that sense, we need something called like an accumulator. So it's gotta be saved somewhere. So maybe if I'm trying to get this total, I'm going to initialize this total as just something like 0, right? And then now I want to add up the numbers. So for a number in 1, 2, 3, 4, 5, 6, 7, 8, 9, I'm not going to write that out. That's too long. I can write it instead in what? This part you can help me out in. Instead of writing a list of 1, 2, 3, 4, 5, 6, 7, 8, 9, I could write. Can you start in the negatives? I believe so. I haven't tried that. We'll try that out. Range 10, yeah. Good. That way we don't have to write it out. 1, 2, 3, 4, 5, 6, 7, 8, 9. And what do I want it to do? So there's a few ways to get this to work. Let's go with the longer way of writing it, which is a little more clear. So I want my original total, and I want to add whatever the number is. So the number is going to be what? It's going to be 0, or yeah, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But there's a couple ways to approach this. So this way by itself, it's going to include 0, right? It's going to, so I'm going to have 0 plus 0. All right. If you didn't want that, you can say start at 1. Right? That works. Or you can just give it an extra 1 right now, right? So you can also add the 1 over here. Right? Because if you're going to start at 1, and this thing by itself is actually 0, then you can add the 1 here, or you can add the 1 here. Whichever you choose, it depends on what you're trying to do, but just be aware that you have some flexibility in your calculation, right? So let's try this one. So that means range 10, we're going to start at 0, but I didn't want 0, I wanted 1. So this will add the 1 for us, right? So just be aware of that as you look at people's code. Sometimes they do that that correction right here in the range, or they do it over here. Both are fine. And now what's this going to do? We're going to add the original total 0 plus 0 plus 1. So that's 0 plus 1. And I need it to go back to the original one and like save it there. So I basically wanted to overwrite the original total with this total plus 1. So I need to save it. Total equals. Right? Does that make sense what we're doing? So this range 10, that's going to give us 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But I didn't want 0. I want it to be 1. So I can add the 1 here. Right? I think I did want the 10. Shoot. Never mind. Sorry about that. I did want the 10. Sorry about that. So when it gets to 9, then it'll be 9 plus 1 is 10. Okay, so we did want that. Let's try it. Hey, nothing happened. Did it? Did something happen? Print it. Yes, very good. I did that on purpose just because it's such a big cause of frustration. We're like, why isn't anything working? It's the print. You're right. All we did was create it, but we didn't print. So now we can see the total is 55. Okay, so with the loop, we can easily do a whole bunch of tedious calculations like this and make it nice and easy.
Question?
Yes.
I think it's obvious, but ending the indent ends the loop?
Good question. Thank you. Yes. Once you leave the indentation, you're outside of the body of the loop, and now you're just back to coding outside of the loop. So yes, if you want to add more stuff within the loop, then you should stay within the indentation. Yes. Thank you. All right. Let's see. Why don't we try looking for an example that will have a lot in it. Let's try this example. It's going to have everything we've done so far, but the main objective is everything is out of place. So for this challenge, that I believe will be our final activity for today, reorder this code so that it will work. Okay, this should also be in your notes, I believe. Ooh, good one. Yes. So why did you end up with 1, 3, 6, 10? So that looks like you're printing inside the loop. And you know what? That's sometimes something you want to check. Some people call it like a canary. It's like telling you what's going on, like inside the cave, even though you're not in the cave. So like you want to know what's going on inside this loop, you can try printing within the loop. So if you print the total, which looks all messed up now. If you print within the total, I'll get rid of this for now. It's going to do total plus one and then print. Then next, total plus one, print. Or plus the next number, print. And then that's actually a way for you to check if your code is running correctly or not. So this is a pretty commonly used technique to see if the loop is doing what you want. Yeah. But if you don't want to do that and you just wanted to print the final total, then yeah, we would keep it outside the loop. Sure, you're welcome. Okay, why don't we take some time to reorder this? This won't work. And let's see what you get. And put up the red, oh, sorry, the green, okay, once you are okay with it.
Can you put it in the notes?
Oh, yes. Someone put this challenge in the notes.
Yeah, will do.
Thank you, thank you.
So I joined back in, are you coming straight out of the lesson notes or out of the instructor notes?
The lesson notes. I kind of jumped around. It's a cumulative sum challenge. And you'll know you got it to work if you get this listed. Looks like it's going well. It turns out we're gonna have some variability in this answer, but there are some definitely key places that the code needs to be changed. Just curious, anyone want to paste what they got, if you're able to? I know some people are on different devices. Yep, you can already see some are different than the others, and they will all work. All right, let's try to fix this. Oops. Down. So you'll notice that in everyone's answers that we're specifying, we have a for loop in here, and it's going to be doing stuff. And some of the stuff needs to be specified beforehand, like the data. And looks like we have two of those accumulators, right? So like those placeholders that were empty that are going to allow us to save some type of intermediate step that's going on within the loop, right? So basically, as long as you have the main order of those accumulators first, so for example, if you have your data first, your cumulative, and then your total, right? So you start with your data, and then you have your blank list and your 0 for your total, then any order of this will be fine, right? The next looks like you have your loop that's going to start. And then what? If I press enter, it's automatically going to do, it's automatically going to do that indentation that I see in all of your answers. Right, so let's see what we want. We want it to get our original total and then add the number and data. Next, we want it to get this total and then put it back. Right? And then we have one last step. Whoops, sorry. One last step is to print out the cumulative. Okay. The two things that we had to also watch out that weren't in this code were the two indentations needed because these are a part of the for loop. When we get it, we should get our answer. Okay, any questions on our concepts for loops? I do want to mention one thing is we were using for loops and a bunch of like small, easy, relatively easy to handle data structures, like a list with 4 elements. But remember when we were doing things like creating graphs, or we were doing like slicing of things. If you have repetitive tasks that can be programmed, like maybe you're going to be creating a variety of different graphs, but you're going to iterate them for like different countries. So you can actually put your plots within like a for loop, and that way you can make like 10 plots like with one chunk of code. Right? So for loops are very, very versatile. And I'm sure as you are continuing on your coding journeys, you'll be using them substantially.